Hello, everybody. I am João Gabriel. I have recently concluded my master's in computer science by the University of São Paulo, advised by Professor Alfredo Goldman. And I'll briefly talk about my work, which was implementing cold start reduction techniques on Globus Compute. So just a quick reminder on the cold start, which is basically the time taken for the infrastructure to be initialized before executing a function. And then we have some possible solutions in literature, such as keeping infrastructure activated, predicting function invocation, reducing install time of dependencies, or even batching function invocations so they all run on the same infrastructure. And then our approach was to create a new engine for Globus Compute based on the high throughput one. And this new engine, we implemented two warm start techniques. The first one was to increase the keep alive time of resources, which we also made user configurable. And we also created a new test dispatch algorithm. So regarding the keep alive time, the first thing we done was to increase it from 1 to 5 minutes. And we chose this value from the hypothesis from the Globus Compute dataset study, which claimed that 93% of the functions that were used on the service would benefit from a bigger cold start, a bigger keep alive time. So that's why we chose this value. And in the meantime, we also made it so that users could configure this keep alive time so that they could use what fits best their workflows. And then the most important technique that we implemented was this new test dispatch algorithm. And our idea was to make functions run on resources where they had previously been executed. So rerouting of these functions. And the reasoning behind it is basically that Python imports are relatively faster for libraries that are already loaded. So here we have a quick example with the NumPy library, and we can see that the second import is several orders of magnitude faster. So the idea is that if we can make a function run somewhere where the worker already has the dependency downloaded, we can save up all this import time, making the functions run faster. Then to achieve that, we first did a propagation of the UID so that both managers and workers could see which functions they were working with. Then we changed how managers dispatch tasks to workers. And basically, we have now a function worker map that maps each function UID to a list of workers that already executed this function and a set of busy workers to know which one of those are active. And then from this mapping, we try to assign a function to a worker that executed it in the past, so we know that its dependencies will be already downloaded. And then we also changed how the interchange sends these tasks to the managers with a similar mapping from function UID to a list of managers which controlled these workers. And finally, we redesigned the dispatch algorithm. So we're now iterating over tasks instead of managers, checking for available slots. And then we use the mapping to try to assign tasks to the managers that already executed that function in the past. And if that's not possible, then we just use any available manager. Then to check if these modifications were positive to the system, we conducted an experiment with two TAPS benchmarks, the molecular design and Cholesky factorization ones. And we tested three versions, the original Globus Compute version from this commit, that's where we started the modifications, the Keep Alive version, which is an intermediate one, only with the 5 minutes of Keep Alive time, and the Warm Start version, which contains all the modifications. And we ran it on an EC2 instance with 4 CPUs and 16 GB bits of memory, with two managers, each one of them with two workers. Regarding our results, we have 27 runs for the experiment for each version, 25 for the original, purely due to time and financial constraints. And for each one of these executions, we extracted some time averages by function. So we analyzed four intervals, the execution time, which is basically how long the function takes to run, the assignment time, that is how long it takes for the interchange to assign a task to a specific manager, the total task time, which is the moment the task arrives in the endpoint until its result is returned, and the full experiment time, which is basically the whole workflow. And since we have this by function, so we have 8 time averages for each one of the first 3 measurements, and the last one we have only one for each experiment. So we have a total of 25 different measures And then we apply the Mann-Whitney test on the distribution of the time averages to check if our versions were better than the original one. So talking briefly about the results, since we don't have much time. From execution times, the Wormstar version was better for all functions. For the assignment times, we have it being better for 7, and total task times, it was better for 6. And all the other cases, it was the same. So for all the measurements in this work, the Wormstar version was at least the same as the original, but for the majority of the ones, it was better. And the keep alive time is somewhere intermediate. It was a little bit better than the original for more functions, but also not as good as the Wormstar version. And regarding the full experiment time, to illustrate a little bit better, I have this box plot, and we can see that while the original version, the workflow takes almost an hour to complete, the Wormstar version makes it so that it's completed in about 1,000 seconds. And we can see also that the Keep Alive version has some good performance, but it has a huge variance with some executions being as slow as the original and some as being as fast as the Wormstar version. But of course, this experiment was somewhat short. We had few runs and we had slow machines and not many functions, libraries, etc. So of course that we need some better experiments to be able to make any affirmations regarding the improvements. So that's, I think it's the most valuable research opportunity is to try to do further experimentation. So trying to increase the size and complexity of workflows, increasing functions, invocations, libraries, etc. Maybe changing some specifications, such as the number of managers and workers or the system memory and CPU. And we can also analyze other metrics, such as the resource usage and scalability with these new versions. And we can also try to search for new Wormstar techniques. So maybe we can try to identify dependencies. So instead of rerouting functions according to specifically where this function has run in the past, we can just try to search for any worker with the same dependencies. And we can also try something like an intelligent keep alive time, where the system can try to infer a optimal value that will make the resources be used in the most adequate way. And that's basically it. Thank you, everybody. If you have any questions, just ask. And here I have the repositories for both my modifications and the auxiliary programs that made the experiment, the statistical analysis, and so on. Thank you.